Welcome to today's lesson. In this tutorial, we will state the local maxima and minima for various functions, and we will use correct notation to describe the increasing and decreasing intervals for various functions. So we're still in our graph reading section, so we're continuing here. We have four more terms that we can use to analyze and describe our functions. Let's first talk about the local maximum. Maximum is the singular. On the objectives I said maxima if we have more than one. A local maximum is the point where a graph turns from increasing to decreasing, or in other words, it's the highest point of all of the nearby points. So if our graph goes from an increasing to a decreasing part, then we would have a local maximum right there at the top. So it's the highest point of a localized domain. It's like the top of a mountain. A local minimum, again, minimum being the singular, minima being the plural, is the point where a graph turns from decreasing to increasing, or rather the lowest point of all nearby points. So if we go from decreasing to increasing, then we would have a minimum, a local minimum. Increasing intervals and decreasing intervals, well, we sort of just illustrated that. In increasing interval, we always read our graphs from left to right. An increasing interval would be the interval from left to right where a graph goes up. So basically think about walking up a mountain. From left to right, you're going upward. Decreasing interval, of course, again, reading from left to right, is the interval where a graph goes down. So let's say you get to the top of the mountain and then you ski down the other side, then we have a decreasing interval. When we're describing these intervals, we only use x coordinates. That's very important to note. We will only use x coordinates. It really doesn't matter what the y coordinates of these points are. We only use the x coordinates to describe our increasing and decreasing intervals. Okay, now that we've seen some vocabulary, let's get started with our first example. Use the definitions that we just learned to analyze each of the graphs and state the information. Assume all turning points have integer coordinates. Again, if it looks like it crosses at a nice value, then we're going to assume that it is. It's not a decimal or a fraction or anything like that. Let's first talk about the local maximum in this first example. Now I've got local here, so I'm talking about in a restricted domain, and I can see that we've got basically the top of a mountain right here. This is not the highest point of the graph entirely. Obviously the graph goes up forever. We're not talking about the ultimate maximum. We're talking about a local maximum. If we can sort of restrict this graph to an area code, like with phone numbers, is there a restricted domain such that we can find the top of a mountain? And there it is. And that's the ordered pair 2, 2. So the local maximum is 2, 2. Now let's look for a local minimum. Again, we're not looking for the overall minimum because this graph points all the way downward. We're looking for where are we going from decreasing and then turning to increasing. And it happens right here at the bottom of this valley. And that ordered pair is -1, -4. Once you're able to find the local maxima and minima, now we just need those x coordinates to help us to describe the increasing intervals and the decreasing intervals. So it's important that we note this x coordinate of -1 and this x coordinate of 2. That's why we need to find our maxima and minima, because then we can see where we're increasing and decreasing. So let's start with increasing. We are, obviously we're going down, 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 and then we turn to go up, 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 and then we turn to go down, 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 down. I'm interested in the increasing part, which happens in between these two x coordinates. We are going up the hill in between these two x coordinates. So we are increasing from -1 to +2. And that's it. That's all we have to do. We're going to describe it using interval notation from -1 to +2. That's the interval where we are increasing. Now, we will always use parentheses. Let me make that as a note. Please put this into your notes. Always use parentheses when we're talking about increasing and decreasing intervals. And why is that? Well, let's say we're just standing right here at the bottom of this hill. If we're literally just standing in place, we're not increasing, we're not decreasing, we're just standing still. You increase over an interval of numbers. That's why we will never include the endpoints. Once we get to the top of the hill and just stop, we're not increasing, we're not decreasing, we're just stopped. We increase over an interval of numbers, so we never use the endpoints. We will always use parentheses with increasing and decreasing. We are not increasing anywhere else in this graph, so now we must be decreasing in the other locations. And we said we're going down, 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 down here, and down, 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 down here. So we need to describe this interval for decreasing, and we need to describe this interval for decreasing. So let's describe this interval. Where's the first number in this interval where we start to decrease? Well, since we're going all the way that way, we must be starting at negative infinity. And we're going to go from negative infinity all the way to this x-coordinate of -1. So we're decreasing from negative infinity to -1. And then there's another interval where we're decreasing, and it starts right here at the x-coordinate of 2. And it continues all the way, well, all the way to positive infinity. It doesn't stop. So from 2 to infinity is our other decreasing interval. And what did we learn in a previous tutorial? If we have multiple intervals, we have to union them together with our union symbol. So sort of like when we were talking about domain and range, you need to train your eyes to see when you're seeing left and right and when you're seeing up and down. Increasing and decreasing intervals are all along the x-axis. That's why it's important to find the maximum, the minimum, so you can use these x-coordinates. Notice that this x-coordinate of 2 and this x-coordinate of -1 are the only numbers that we use in our increasing and decreasing interval, because it's important to know where our graph is being split up into decreasing to increasing to decreasing. Your eyes are going to be tricked maybe a little bit by the curve that's going all the way down here and then all the way up here, but it's not about down and up. It's about left and right. So once you can mark those 2 or 3 x coordinates, then you can see your intervals. Let's practice that with example 2. So here's another curve. Let's first identify the maxima and minima. Let's start with the maximum. I see a very high point right here, and I think that's it. That's just the very top of a mountain. That ordered pair is 0, 2. We have 2 local minima, so I have one here and I have one here. I don't care which one is actually lower. I care that there's a lowest point here and that there's a lowest point here. So let's name those. This is -2, -3. These are just ordered pairs, so I use the word and or maybe even a comma. These are not intervals. I do not use the union symbol unless I'm talking about intervals. And the other ordered pair, 1, 2, 3, comma, -2. Once you've identified your ordered pairs, you have the x-coordinates that you're going to be using to describe your intervals. This x-coordinate of -2, this x-coordinate of 0, and this x-coordinate of 3. Those are the only numbers that we're going to be using when we're describing our increasing and our decreasing. Let's see if we can find the increasing first. And I'm going to be reading from left to right. So let's see, I'm going down and then up. Okay, so this is the first increasing interval. I'll describe that. And then I'm going down. Oh, but then I turn again and I go up. So this is another increasing interval. So let's describe these 2 increasing intervals. This one happens between -2 and 0. So I'll simply say -2 and 0. Remember, just always parentheses with this. union, let's see where the other one is. It picks back up at 3 and goes all the way to infinity. So that's what I'll say, 3 to infinity. Pretty simple. Everywhere else, we must be decreasing. So let's see. Yep, that's right. We're going down, 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 down here. So this is a decreasing interval. And then we went up and then down, 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 down here. So this is also a decreasing interval. So let's describe these. This one starts at negative infinity because it starts all the way at the far left and goes to negative 2. So negative infinity to negative 2. And then since there is another one, I'm going to use the union symbol, and it's between 0 and 3. So I'll say between 0 and 3. If you've done this correctly, you should be able to link all of these intervals together. Sort of like you can see visually that you're going down and then up and then down and then up in the graph, you should be able to see it in the intervals. The first interval is from negative infinity to negative 2. And then it connects from negative 2 to 0. And then it connects from 0 to 3. And then it connects from 3 the rest of the way to infinity. You should be able to connect these all the way through from negative infinity to positive infinity if you've done it correctly. So now let's look at our third example. We'll look at one more here. Let's find our local maximum, and I see only one, the little highest point right here, and that's at 0, 1, 2, 3, 4. So 0, 4. I'm looking for a local minimum, but I don't see one. Remember, a local minimum has to be the lowest point of like a little valley, and we have to go from decreasing to increasing, and we don't have one. So I'm just going to put none. Don't leave it blank because then I might think that you don't know what it is. Put the word none when it's none. So now let's do increasing intervals and decreasing intervals. Well, we only have one number that we're interested in, and it's right here, 0. So that must separate our two intervals. We have an increasing interval right here on this side of 0. So I'll simply say from negative infinity to 0. And then the other side must be the decreasing interval. And that's exactly right, from 0 to infinity. So that looks like a little bit simpler. Since we only had one maximum, we only had two intervals that maximum was separating. Let's look at the next example and add a few more things just to make sure that we are understanding this. Here's one where we're starting with a closed dot and we're ending with a closed dot. And let's see what that does for us. If we're looking for a local maximum, again, we're looking for the top of a mountain, which I see one right here. Some people want to think that this is a local maximum. If you look at the definition reads that we have to be turning from increasing to decreasing. Since we're not turning to decreasing, this is not a local maximum. We only have one here, and it's at the ordered pair -1, 2. Same sort of thing for the local minimum. We have the bottom of a valley right here. This is not a local minimum because a local minimum has to turn from decreasing to increasing, and this is not because it stopped. It's not going from decreasing to increasing. Not a local minimum. So this ordered pair 2, -4 is the only one. Okay, so we have the important numbers, the x coordinates of those two things. We have the one at -1 and we have the one at 2. And if doing these little tick marks helps you on your curves, that's I encourage that. So let's look for our increasing. You don't have to do the increasing first. You can go from left to right. I like to do the increasing first. I'm going up, 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 up. From here to here. So I guess we do have another interesting x coordinate right here because we're not using the negative infinity. We don't have an arrowhead, we have a starting point. So we do need to know that 1, 2, 3, -4. So from -4 to -1 is where we're increasing. Oops, -1. Now remember, we're always using parentheses. I don't care that this is a closed dot. That doesn't matter. If you're just standing at the base of a hill, you're not doing anything. You're not increasing, you're not decreasing. We always use parentheses. That's sort of the point of this problem as well. I don't care the closed dot. That might happen, or that might change what the domain looks like, but we're not talking domain. So here's increasing. We went up, 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 and then down, 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 and then up, 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 up again. Here's another increase. Oops, I went too far, sorry. Here's another increasing curve. And again, we have to stop right here. So we do need to know what that is. 1, 2, 3, 4, 5. So we're going from 2 to 5 as well. So I will union that together and go from 2 to 5. Same sort of thing. It's a closed dot, but who cares? We're not increasing in a single point. We increase over an interval of points. So please make sure you only use parentheses. Decreasing must be the only other interval, and that's right in here, down, 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 down. That's in between these two x coordinates from -1 to 2. So because this function starts at -4 and ends at +5, you can piece it together from -4 to -1, -1 to 2, 2 to 5, instead of the infinities like the last example. And we have one last one. I put in an open dot here on one side and an arrowhead on the other side. And let's see what that does for us. So local maximum, well, let's see. Oop, I don't see one. Remember, local maximum has to be the top of a mountain. And I don't see one, so we're going to put none. Local minimum, I see one right here. There's a local minimum, and that is 0, 1, 2, 3, 0, -4. So that must separate our two intervals. So let's first talk about increasing. This is down, 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 down. Aha, up, 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 up. And we're, let me mark that tick mark. I didn't do that. Here we are. And it's important to know that we actually are stopping right here. So this is our increasing interval. And I don't care if it's an open circle or a closed circle. It doesn't matter. I'm always using parentheses from 0 to 4. This might look like an ordered pair because, you know, it's a parenthesis separated with two numbers and a comma, but this is an interval because we're talking about intervals. So you just need to know that that's between these two x coordinates from 0 to 4. Okay, decreasing, the last one is right here. Now this one does go on forever this way, so we're starting at -infinity and we're decreasing all the way until we get to 0 along the x-axis from -infinity to 0 parentheses. So I think I might have said last example at some point. I might have said that a few times. I guess I do that. Sorry. Well, I do have two more problems that I'd like to do, but I'd actually like for you to try them yourselves. So I'm going to ask for you to pause the video and for you to fill out these graphs yourselves. The first one, you're going to construct a function that has a local maximum at this ordered pair and local minimums here and here. Just draw a function that has these things true. And then the second one, construct a function that is increasing on the interval here and decreasing on the interval here. Why don't you pause the video? I'm going to do the same, and then we'll check our answers. Pause now, please. So I hope that you tried both of these examples. I've started them for you. My local maximum I labeled as a red dot, and here it is. My two local minimums I labeled as blue dots, and there they are. So if I'm going to have these be the lowest points of parts of the curve and this be a highest point, then this curve must start somewhere out like this and come down and be that lowest point. But then it has to be coming up to this point and then curving back down. And I'm just going to come all the way down to this other point right here. And again, it has to be decreasing and then back up to increasing. So your curve might have looked something like that. Of course, these three ordered pairs had to be plotted exactly, but then it doesn't really matter exactly what it looks like here. You might have actually just connected the lines with straight lines. I like to do the curve. So that's our first one. The second one, I labeled the two important x-intercepts, or x-coordinates, excuse me, the 1 and the 5. If we're increasing on this interval from negative infinity to 1, that's over here. That must mean that we're going upward. So I'm just going to start with the graph that's going upward. I'm just going to go up to here. Okay. Then we start to decrease on this interval in between these two values. So at some point there has to be a local maximum. So I'm just going to, I guess I'll just put the local maximum right here, and I'm going to turn and start to decrease. And I'll decrease, 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 decrease to there. Now, I don't know exactly what happens here. Maybe it's going to be some sort of an open dot. Maybe it's going to be some sort of a closed dot. Or maybe I'm just going to turn and start to increase somewhere else. It doesn't actually say that we can't, as long as the function has these attributes, then we're okay. But since it doesn't say that it's increasing anywhere else, I think I'm just going to be safe and just stop at a point right over here. So I'm definitely, now I need an arrowhead over here. So I'm definitely increasing from negative infinity all the way to the value of 1. And then I turn and I start to decrease, and I'm only decreasing between 1 and 5. So this might be an open dot or a closed dot, and hopefully you tried those and you did well. We'll practice this more in class, and I will see you then. Thanks for watching this tutorial. See ya.